Hey everyone, thank you for joining me today. I have a Kenmore front load washing machine here that obviously is having the LE code problem. When I push the start button to have it run, it's making a weird bumping or grinding noise. It's preventing the unit from spinning out properly. It'll do a little bit of agitation and then it errors out. Now this is for a Kenmore, but really it's made by LG. If you open the door, you're going to find a model number that's going to start with 796 or possibly a 795. If you have either of those numbers, it tells you it's really an LG product. And I want to show you how to diagnose and fix this today. Now, if you get this code, it means that there is a motor lock issue. It is not able to spin properly. And there are three different ways that this can happen. Either there's a physical obstruction, there is a board problem that needs reset, or there is a problem with your rotor position sensor, and we're going to go through all three. The first thing that we want to try to check is for an obstruction in the drum that could potentially prevent the motor from running properly. When I open the door though, there's still water in it when the LE code popped. First, let's attempt a reset of the unit so we can drain the water, and this could fix the machine as well. To do this, unplug the unit and let it sit for 2 to 3 minutes. When it's unplugged, press and hold the power button for between 5 and 10 seconds. Go ahead and plug the unit back in. When you plug the unit back in, the LE code should have disappeared and the unit has been reset. You should be able to run the unit to drain the water. This could also potentially fix the LE code problem by itself. Let's go ahead and spin the drum and check for noise and obstructions. In the case of this washing machine, there aren't any major abnormal noises and the drum action is not bad. If the drum was stopping abruptly when I spin it, or you could hear something major, you could check the tub and take it apart for obstructions, but everything's fine, so we do not need to. Next, let's go ahead and investigate the motor and rotor position sensor system. First, make sure the unit is unplugged again at this point. Go ahead and move the unit to be able to access the metal panel at the rear of the washing machine. At the rear, there are 4 Phillips head screws that need removed from the rear of the machine. Once you have these 4 screws off, just go ahead and slide the plate off to expose the rear of the unit with the motor. With the cover off, let's go ahead and remove the rotor plate. To do this, you need a 17mm socket wrench. To remove it, put the wrench on the rotor bolt and turn the wrench counterclockwise. This part can be very hard. When you turn the bolt, the entire rotor system wants to move as well, and it's very difficult to move this with one hand on the rotor and the other on the wrench. One suggestion that I have is to use a rubber hammer and tap on the socket wrench as hard as you can when you hold the rotor in place. This will help force the bolt off, making the job a little bit easier. Once you have the bolt fully off, you now need to remove the rotor itself. Note that it has large magnets on the inside of it, and it's very hard to pull off because the magnets love to hold the rotor system in place. When you try to remove the rotor, apply equal pressure using your hands on each side of the rotor, and don't pull just from one side or else it could damage the magnets. Gently try to pull it off at the same time, slowly wiggling just a little bit on each side if you need to. With the rotor off, inspect the threads of the rotor that connect the plate and the shaft. Check to see if there are any threads on this hub that are severely worn. If there are, some models of these rotors allow you to just buy and replace the rotor hub itself with these 3 screws. I will have a link for that in the description as well as any other item used in the video. Now, if the threads in the rotor hub check okay, the next step is to go ahead and inspect the rotor magnets. These should be smooth without any wear, damage, or obstructions on them. Sometimes the magnets could wear down or they could get cracked, burnt, or damaged in some other way, causing the motor to fail to spin properly. There's no way to replace the individual magnets, so you'd need to buy a new rotor system. Now let's go ahead and take the stator itself off. This is the motor that runs the whole washing machine. You need a 10mm socket wrench to remove these 6 long screws. Unlike the rotor bolt, these are actually quite easy to remove. Now when you remove the last one, the stator will typically want to fall off, so hold the unit in place as you remove the last bolt. When you get the last bolt removed, there are 2 sets of wires that are installed on the stator system that you need to remove. While holding the stator in one hand, you need to remove the 2 wire harnesses that are installed. If you have any difficulties taking these off, you may need to use a flat-bladed screwdriver or needle nose pliers to assist to press in on the sides of these clips. With the stator now finally off, go ahead and inspect the edges of the magnets of the stator, also the stator wires itself for any burn or damage marks. But if you do see anything that looks damaged, chances are that stator's bad and it needs replaced, and I'll have a link to these stators in the description. Now, let's go ahead and deal with the rotor position sensor. It's mounted on the inside of the stator, and it's frequently the culprit of the LE problem. The sensor is held in to the inner ring by a small retaining tab on the inside of the unit and then 3 tabs on the outside. Use a flat-bladed screwdriver to press in on the sensor and then remove it from the stator. You could remove it with the 3 outer tabs, but I just needed to remove this one to get it off in my case. Now that we have the sensor off, let's go ahead and test it and see if it's bad against a brand new one that I have here. To test the sensor, set your multimeter to ohms resistance. If you don't have a self-ranging meter or know what that is, it may need set to 20k ohms. There are 5 connectors on the sensor as numbered here on the screen, 1 through 5. You want to insert one multimeter lead to the 5th connector, then the other lead on the 1st connector. You should get between 5 and 15k ohms if it's good. Then move the lead from the 1st connector to the 2nd connector while the 2nd lead is still on the 5th. You should have the exact same value between 5 and 15k ohms. Oh, it looks like we're getting between 5 and 600,000 ohms, and the number keeps going up as I hold the leads into this position sensor. This is definitely not right. Here's the new rotor position sensor. Let's go ahead and do the same tests. We get roughly 10,000 ohms on the 1st and 5th pins, and then nearly the identical settings on the 2nd and 5th connectors. It's clear that the rotor position sensor is bad. Now, you can do additional live voltage tests to the sensor, but it's rather difficult to do these, and usually the continuity test is enough, so I'm not going to do those tests today. But if you are worried about the sensor, go ahead and replace it. It is not very expensive to do. If you do need a sensor, I will have a link to an affordable one in the description. And if you buy those from the links, it does help the channel out, by the way. To install the new rotor position sensor, you'll notice the 3 small pegs on the outside of the stator ring. You need to position the sensor and snap it onto these 3 outer pegs, and then the inner peg that we used to take it off earlier in the video. Should snap into place pretty easily and securely. Another thing to look at, if the rotor position sensor may not have been the culprit, is the wires that actually go to the stator that we had removed earlier. Sometimes a wire could be frayed, or one of the connector wires on the inside of the harnesses could be damaged or separated. So it's worth looking into these areas for damage or anything out of place if you haven't found any problems up to this point. But since we do know what the problem was, let's go ahead and reinstall the stator to the washing machine tub. To do this, I'm going to insert 2 bolts gently to mount the stator on the tub. I'm screwing them in only partially just to make sure that the stator will not move. Now I'm going to go in and reinsert the 2 wire harnesses next with the stator on. You should have a decent amount of room to insert these 2 harnesses back into place, and it should be rather easy to do. You can only insert these connectors one way. This was much easier to do than trying to hold the stator in one hand and then try to snap them into place, as that stator weighs about 10 pounds. Once you have the 2 connectors in place, go ahead and use the 10mm socket wrench to install the other 4 bolts. Fully tighten the other 2 that we just put in. With the stator on, go ahead and reinstall the rotor onto the stator. Note that the threads on the rotor hub need to match the tub shaft generally. The magnets are also going to try to pull the plate hard onto the shaft, so gently align them and place it as best as you can. Now, the magnets may also try to push the rotor plate away to where you can't get that bolt to thread and be inserted properly to that tub shaft, so you may need to press the rotor plate towards the tub to insert the bolt. But before you insert the bolt to the tub shaft, use some blue thread locker on the threads of the bolt. This will make sure that it fully secures to the tub shaft when you screw it in. Put about 5 or 6 drops on, and then go ahead and tighten the bolt back into place with a 17mm socket wrench. I'm going to have a link for the small vial of thread locker in the description if you don't have any, because buying a full bottle, you may never use it. Now with the bolt installed, go ahead and use a hammer to tighten the bolt up a little bit, like we did to remove it in the first place. Give it a few extra taps to make sure that it's tight on the tub shaft. Finally, go ahead and install the rear plate with the 4 Phillips head screws. We are now totally done with the repair. Go ahead and move the washing machine back into place, plug it into electricity, make sure the washing machine hoses are on, and go ahead and test the washing machine. Now at testing, it's crazy to think that simply changing a sensor would affect the noise of this machine, but that's what happened. There's no thunking noises at all, and it runs very smoothly without issues. The machine now runs the full cycle with no problems, and it's spinning absolutely perfect. This machine is fixed. I hope this video helps you out with your machine. Make sure to remember all the tools and parts are linked in the description, and I hope you have a great day.